The board geometry and thickness is essential in properly propagating the mechanical constraints to the electrical designer. In this example, we will create a new board outline. We'll do this by creating a sketch that's 180 by 135 millimeter. We will take that generated sketch and extrude that element to 1.59 millimeter, which matches our Xpedition stacko. Once the extrude is created, we will change the color of it using the visualization command to green to match the PCB design. We also need to chamfer the top left and bottom left corners of the board outline, which we'll do by 21.2 millimeters using the chamfer command. Finally, to finish the geometry, we will create a cutout in the upper left corner. First, we'll create a sketch that's 25 by 10 millimeters, and we'll take that sketch and extrude that element to subtract the area with the board geometry and the sketch we just created. Now that the board has been finally created, we will open up the PCB exchange settings and tag that geometry as a board attribute, which is required to properly pass the geometry to Xpedition layout. Next, we will define our mounting holes. We will select the hole command and choose the primary surface of the board outline to place our mounting hole. Now that we have a location, we will define the diameter of the hole to be 3 millimeter and create the mounting hole. Once the hole is created, we will go back to PCB Exchange, go into the hole attribute, and tag our newly created feature as a non-plated mounting hole. We will now create a placement obstruct as well as a routing obstruct. In this first sketch, we'll create a 13 by 22 millimeter outline on the top surface of the board. We will then extrude the placement obstruct to have a 1 millimeter height. We will also create another sketch for a routing obstruct around the mounting hole, as we do not want any traces near the mounting hole. This needs no height. We will go to PCB Exchange in the Area Attribute section, first associate the placement obstruct sketch that we just created as a placement obstruct. We will repeat the process for the routing obstruct by selecting the second sketch you created and changing the subtype to routing. Finally, our last action in NX is to place electrical and mechanical components that exist in the design. We will go into the Assemblies tab and browse to a 24-pin SOIC. In this case, we want to first mate the SOIC to the top surface of the board outline using the touch align constraint. We will then use the move command to drag and rotate the electrical component to the bottom center of the design. Once the placement is complete, we will place a screw from the NX library. This library element has no electrical representation in the physical layout. However, it is useful for the electrical designer during interference studies as well as component placement. Similar to the SOIC, we'll use the align touch to mate the screw to the top surface of the board, and then we'll use the axis constraint to place it in the center of the mounting hole. Once this is complete, we'll go into PCB Exchange and toggle the component attribute. We will give the SOIC a reference designator, as it is the primary key in Xpedition. We do not need to add any attributes to the screw, as it will be exported through the clone assembly command. We can finally send the baseline to Xpedition. In Xpedition, we can open MCAD Collaborator. Here, we can see a pending collaboration file to review. As we select it, we can preview the board geometry, components, and obstructs that we created in NX. We can apply that baseline and bring in the data. Since we exported the screw through the clone assembly command, we need to run through the import assembly command in Xpedition to get the 3D model, alignment, and orientation in Xpedition. We are now synchronized with the mechanical domain and can run subsequent incremental interchanges between Xpedition and NX.